there, welcome back to practice session in Bhanju classes. So let's quickly start practicing the questions one by one. So here comes our first question. Observe the following pattern and find the missing digits. So here we can see that simple 11 square is 121. Now if we see the square of 101, 1, 2 and 1 are already there, but the number of zeros between 1 and 2 and then 2 and 1 depends upon the number of zeros in the question over here in the middle. And then if we see the similar thing over here, we can see 1 is there at the extreme ends, 2 is there in the middle. Now number of zeros between 1 and 2 and 1 depends upon the number of zeros here in the question. Similarly, we are going to fill in the number of digits over here as well. So here I can see 1, 2, 3, 4 zeros. So I am going to put 4 zeros over here and 4 zeros over here in the answer. Similarly, let me write the answer for the next question. So here again I will be writing 1 at the extreme ends and 2 is going to be in the middle. So how many zeros will be there? Let's quickly check. 1, 2, 3, 4, 5, 6. So let's put 6 zeros. 1, 2, 3, 4, 5, 6. And here also 1, 2, 3, 4, 5, 6. So this is how we can find the missing digits by observing the pattern. So let's see the next question. What will be the unit digit of the square of the following numbers? Now, if we have to find the unit digit of the square of the following numbers, then how can we do that? So here you can see that the unit digit in the first question is 4. And the square of 4 is nothing but 16. So that means the unit digit of the square of this number is going to be 6. And let's go to the next question. So here we can see that the unit digit is 9 and its square is 81. So the unit digit of the square of this number is going to be 1. So this is how we can find the unit digit of the square of the numbers. So let's quickly go to the next question now. So the next question is how many numbers lie between the squares of the following numbers. Now we know that between n and n plus 1 there comes two n numbers which are non-perfect squares. So here the n is 12 and n plus 1 is 13. So how many numbers are there between the squares of these numbers? Let's quickly calculate. This is going to be 2 times 12 which is equals to 24. And similarly this is n over here and n plus 1 over here. Now if we have to find the numbers between the squares of 99 and 100, we are going to calculate it again with the formula 2n. So this is going to be 2 multiplied by 99 which is equal to 198. Easy? Let's go to the next question. Find the square of the number 86. So of course we know that if we have to find the square of the number, that means we need to multiply 86 by 86. I can write this 86 as 80 plus 6 as well, and we are finding the square of 80 plus 6. So now we can apply the formula a square plus b square plus 2ab. So let's quickly see that. So this is going to be a square plus b square, b is 6 over here, plus 2ab. So a is 80 and b is 6. Now we can quickly solve it. This is going to be 6400, then 36, and then this is going to be 960. Then we can quickly add the numbers 6400, 960 and 36. This is going to be 6, this is going to be 9, this is going to be 13, and the answer is going to be 7396. So let's see what next is there for us, and the next question is find the square root of 169 by the method of repeated subtraction. We know that we can keep on subtracting the consecutive odd natural numbers, and then we need to do it until and unless we get the number zeros, and at the end we are going to count that how many steps were there to get the number 0. So let's quickly see this. 169 minus 1 is 168. 168 minus 3 is 165. Then we are going to take away 5. So this is going to be 160. 160 minus 7 is 153. 153 minus 9 is equal to 144. 144 minus 11 is equal to 133. 133 minus 13 is equal to 120. Then 120 minus 15 equals to 105. Then 105 minus 17 equals to 88. Then 88 minus 19 is going to be 69. Then 69 minus 21 is going to be 48. Then 48 minus 23 is going to be 25. And then 25 minus 25 is going to be 0. So we need to calculate how many steps were there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That means the square root of 169 is 13. I hope you understood it, but you must have felt that yes, this is time consuming. That's why I have already taught you in the previous videos what are the other two methods to find the square root, that is prime factorization and the division method. So let's quickly see the next question. It says find the square root of the following numbers by the prime factorization method. So let's quickly practice this one also, and we can see that this is divisible by 3. So this is going to be 2, 4, 3, and then again this is also divisible by 3, and then when we divide it by 3, the quotient is going to be 81, and again if we divide by 3 we are going to get 27. If we divide by 3 we are going to get 9. If we divide by 3 we are going to get the quotient as 3, and if we again divide by 3 we are going to get 1. So now we can quickly write the prime factors that I am getting. 3 times 3 times 3 times 3 times 3 times 3, and we know that we can make the pairs over here, right? So we can make the pairs quickly, and we have 3 pairs, and we are going to pick one number from here, one number from here, one number from here, and then this is going to be the square root of 729. Now if we multiply, then we are going to get 27. I hope this is clear. Let's go to the second question, which says the number is 400. So we will be again using the prime factorization method only. So we can see that 400 is divisible by 2, and we are going to get 200. Then again divide by 2, we will be getting 100. Then divide by 2, we will be getting 50. Again divide by 2, we will be getting 25. Divide by 5, we will be getting 5. And then again divide by 5, we will be getting 1. Now we can write quickly the prime factors that we have gotten, that is 2 times 2 times 2 times 2 times 5 times 5. Let's quickly make the pairs, and if we make the pairs we can quickly find the square root now. 2 times 2 times 5 is going to be nothing but 20. Is that clear? How can we use the prime factorization method? So let's see the next question, which says find the smallest number by which 1008 should be multiplied so as to get a perfect square number. Also find the square root of the square number so obtained. Let's start solving the question. So we will be using again the prime factorization method here, and then the number is 1008. So let's use the prime factorization method once again. So we can divide this number by 2, and we are going to get 504. Let's again divide by 2, and we are going to get 252. Again divide by 2, we are going to get 1, 2 and 6. Here again we can divide by 2, and we will be getting 63. Now 63 is not divisible by 2, so let's divide by 3, and when we divide by 3, we will be getting 21. Then divide by 3, again we will be getting 7, and then divide by 7, we will be getting 1. So now 1008 is equal to, let's write its prime factorization, 2 times 2 times 2 times 2 times 3 times 3 times 7. Now here again let's make the pairs. We have one pair, another pair, another pair. So we can see that 7 is not making the pair. So that means 1008 is definitely not a perfect square number. So if we have to make it a perfect square, it says, so what number should we multiply to 1008 so that we can get the smallest multiple of 1008, which is the perfect square number. So this is very simple. So 7 is not making the pair. So we will multiply 1008 by 7, and when we multiply it by 7, what are we going to get? That is 7056, which is actually a perfect square. Now this is a square of what number? So let's quickly find the square root of 7056. Now we know that here we have just completed this 7, right? So now this 2 can be as it is, this 2 can be as it is, this 3 can be as it is, and then we have completed this pair of 7 also when we multiplied. So we can directly take 7 over here, and if we multiply, what is going to be the answer? 2 times 2 is 4, times 3 is 12, and 12 times 7 is 84. So let's quickly see now what is the next question. It says, there are 500 children in a school. For a PT drill, they have to stand in such a manner that the number of rows is equal to the number of columns. So how many children would be left out in this arrangement? So let's quickly see. So first of all, we need to see that we want equal number of students in rows and columns, right? So let the number of students in row equal to x, and similarly let the number of students in column is also x, right? Now we want the equal number of students in rows and columns, so this is going to be x multiplied by x, which is x square. Now we know that the number is 500 and we have to find how many children would be left out in this arrangement. So let's quickly see first of all if 500 is a perfect square number or not. So we can use division method also, right? We can use any method, and this is the first pair of digits from the right hand side and this 5 is alone. Now 2 times 2 is 4. Now 1 is left over. We are going to take away. Now we will copy down these 2 digits and this is going to be 100. Now 2 plus 2 is 4. Now again we know that we need to calculate a number which is either less than 100 or equal to 100. So let's quickly see what number we are going to use here and here, and that should be same number, right? So now let's find it with 2 first of all, right? If we multiply 42 by 2, then we are going to get 84. If we multiply 43 by 3, then we are going to get 129, which is more than 100. So now we can go with 2. So 42 and then 2 here. 42 times 2 is 84, and we are left with the number 16. So this means there will be 16 students who would be left out in this arrangement, and there can be 22 students in a row and 22 students in the column. I hope this question is clear now, and we will go ahead with the next question. Now the next question is, find the square root of 7.29. This time we have the decimal number. So let's use the division method to calculate the square root. So this is one pair of digit and this 7 is alone. Let's quickly see what square number is less than 7, and that is 4. So 2 times 2 is 4 and 7 minus 4 is 3. We will copy down these 2 digits and this is going to be 3 to 9 altogether. Now this 2 plus 2 is going to be 4. And then we can see that we are picking the numbers after the decimal point now. So we need to put a decimal point over here also. Let's quickly try to figure out the next number. Now I know that my n should be same over here, right? So let me try with 7. Is that okay? Because 7 times 7 is 49 and I want 9 only at the units place. So let's try with 7. So here if I try, then I am going to get 7 times 7 is 49, 7 times 4 is 28, 28 plus 4 is 32. So now here let's use 7 and this is 7 and this is going to be 329. So 329 minus 329 is 0 and the square root of 7.29 is going to be 2.7. So let's go to the next question now, which says, write a Pythagorean triplet whose one member is 18. Now we know that what are the terms which we have studied in the Pythagorean triplet. It was 2m, then m square plus 1 and then m square minus 1. So let's say that 2m is equal to 18. Can we do that? Yes. So if we do this, then m is going to be 18 divided by 2, which is going to be 9. Now if m is 9, then let's calculate the other two numbers in the triplet. So one is m square plus 1. So this is going to be 9 square plus 1. So 81 plus 1 is 82. Now the next is m square minus 1. So we can take it as 9 square minus 1. 81 minus 1 is 80. So we have figured out three numbers which are 18, 82 and 80. Is that clear? So what do you think? What is going to be the hypotenuse over here? Of course, the bigger number. So that is going to be 82. So you can say that 82 square is equal to 80 square plus 18 square. So with this, we can quickly conclude our practice session and we have revised all the topics that we have learned. Now, I want you also to practice many more questions, and until next time, take care of yourself. We will meet with the new topic. Bye-bye.